me edit this. So let's look at water temperatures off of North Carolina. Let's look water temperatures here. 7.9. Let's look at details. So marginally warm enough. Marginally. Let's look around here, off the coast of Outer Banks. Basically, the system right now is here. So 82 degrees. You're basically going to have temperatures conducive for development all the way up to maybe the North Carolina-Virginia border. And let's look here, really close to the coast, 79.3. So it's going to be marginally warm enough for the system. So I don't know if this is going to upwell any cool waters because it's been really warm the past few weeks. You might get some upwelling, but then you're going to have a major heat wave coming in the next few days. So let me show you what I'm talking about. You're going to have a major heat wave. So let's go to temperatures. So right after the system, looks like it's going to do an inland track. Let's look at Saturday, the day after the storm. It's going to be in the 90s already. Look at that, 93, 94 degrees. Let's look at Sunday and Monday. It's going to be incredibly hot. I mean, look at this. Let's look later in the week. You're easily going to have temperatures over 100 degrees. Thursday is going to be just dreadfully hot. I mean, let's look at the 79-degree water temps. I mean, look at all these crazy warm water temps here. Wow! No! Oh my God! Unbelievable. Guys, 105, 106. Holy. Jeez. Just please don't be right, guys. Oh, God. Oh, God. Heat. Just crazy. Unbelievable. Oh, God. I mean, okay, let's go here. Let's compare this to 80Z. That's going to be 1, 2, 3, so hour 21. So it's further east. So, and then you'll probably take a track, making landfall in New Jersey. I mean, that's what the NAM nest has been having. It's been having a southern New Jersey landfall, basically, right around Cape May, just south of Atlantic City, and then basically going inland, and then. But I've been looking at spaghetti models, right? Spaghetti models has development chance at, look at this, 80%. 80%. Yeah. So here, let's read the description. An area of low pressure located about 60 miles east-southeast of Wilmington, North Carolina, continues to produce a large area of disorganized showers and thunder showers over the adjacent Atlantic waters and portions of eastern North Carolina. The low is expected to move northeastward near or just offshore of the North Carolina Outer Banks on Thursday, just tomorrow, and then turn northeastward and move along the mid-Atlantic coast on Friday. Environmental conditions are expected to be conducive for development, and a tropical or subtropical cyclone is expected to form within the next day or so. Regardless of development, the system is expected to produce locally heavy rainfall that can cause flash flooding across portions of eastern North Carolina, the coast of Mid-Atlantic, and southern New England, basically us, over the next few days. Gusty winds are also possible along the North Carolina Outer Banks through Thursday and along the Mid-Atlantic and southern New England coast Friday and Saturday. Interests in these areas should monitor the progress of the system and refer to products from your local National Weather Service office. So yeah, so far no advisories have been issued. There's no tornado watches, and the system is like basically gonna take this path right here. It's gonna basically move like this and then probably turn inland, like what the NAM is suggesting. The European model hasn't really been like doing much. Wow, okay, they changed a little bit. It used to be in 1005, 1001. Okay, Euro. Looks like, huh? It's a little impressive. 1001. Looks like we are going to get a pretty bona fide tropical storm. Lower dynamics. Let's look at wind, maybe. Looks like we are going to have a tropical storm. Upper dynamics, MSLP. Okay, so a weak tropical storm. Let's look at the GFS power. I've never heard of that one. Righty. Let's look at the icon run. Okay. So further east. Big tropical wave there. Righty. Let's look at the NavGem. That's another hurricane model. Could be used for hurricanes. Okay, 1,000 millibars. So I have some tropical conditions. Lower dynamics, 850 millibar wind. Not really. Okay, let's look at mesoscale. Let's look at the WRF model. Okay. It's also basically parallel north 997, so probably a moderate tropical storm with maybe 50 to 60 mile an hour winds, perhaps. Because right now, the only reason it's weak right at this moment is there's some shear, and then the shear is expected to weaken very shortly, and it's going to intensify according to this run. This is 32 hours out. This is tomorrow evening, basically. This is tomorrow afternoon. So, I mean, this is still over Gulf Stream waters. The Gulf Stream basically goes offshore like this. You have waters in the 70s here, some low 80s over here, so you're still going to have development. All right. Let's look at that for a moment, and let's look at the other models. Let's look at RAF and MM, which is another WRF model. Basically saying it's gonna go north. Alrighty. Let's look at the RGEM model. The RGEM. Oh yeah, that model doesn't even. It shows nothing. It shows not even a tropical depression. It like shows. Yeah, there's something wrong with that run. Okay, but it's possible. You never know. Let's look at HRRR. Of course, we already looked at HRRR, but just let's look at it from this site. The low, center of the low right now is actually not here, but here actually. Mm-hmm. Okay, I'm looking now off the coast of North Carolina. There are some thunderstorms that are trying to build around the center, like thunder showers, basically. Not, I wouldn't even call them thunderstorms. They're just heavier showers. But the heaviest of the rain is still in some heavy precip here, but the center of the low is right around here. It's south-southeast of Jacksonville right now, the center of the low. And it looks very, very disorganized. When you look at it, it doesn't look like much at all. But a lot of times, convection tries, the center of circulation often tries to go where the strongest convection is, because that's where you have the lowest pressures. So you might have one area, like usually when storms just develop, you could have multiple little mesovortices, basically, like tiny little vortices. Why is something called a mesocyclone? Because it's mesoscale, it's small. So these little mesovortices can rotate around the parent low pressure system until one of the mesovortices becomes a dominant low pressure and will dominate all the other mesovortices and basically conglomerate itself. Usually around the strongest thunderstorm development, once the shear dies down, where the thunderstorms will try to reform around the center. Usually one or the other. Right now, around the center of circulation, there's hardly any thunderstorms. There's a couple cells, but that's about it. It's mostly dry over there. There's very little in the way of precipitation. There is a lot on the eastern and northeast side. And when I look at the base velocities, the winds are very weak. Some very weak wind, very weak. Okay, let's see. Look at the radar. Um, I mean, the development is very slow. There's very slow development. And the large reason for that is because there's a lot of dry air and there's some shear due to an upper level feature that is actually part of the same system. Um, let's go to Northeast Visible Satellite, and I'll show you what I'm talking about, or Northeast Satellite. Because, you know, it is night there. Let's look at the animation loop, and I'll show you what I'm talking about. Okay, let's look here. Okay, so here's the thunderstorm cluster. The low pressure center is actually here, but there's absolutely no thunderstorm development of any kind. So there's a lot of dry air. There's a lot of dry air, largely in part because of the Saharan air layer on the west side. And you see all this blue here? That's fog. That's all dense fog here, or dense fog in low clouds. Not all of it is fog, but a lot of it is. And so that's, you know, basically cities along the East Coast. That's New York City, Philadelphia, Newark, Boston, Worcester, Springfield, Albany, Schenectady, Rochester, you know, Syracuse, Buffalo, here, Philadelphia, Pittsburgh, Cleveland, Charlotte, Raleigh-Durham area, Wilmington, Columbia is basically where the no logo is, and of course smaller towns in PA here. You know, towns like Williamsport, Harrisburg is here, and of course Montreal is here. But even north, you have more towns and small cities, large towns here. Large town here, possibly large town. Toronto, that's London, Ontario there. That's Burlington, Vermont. That is definitely. I don't know. That's Montreal. That's actually Ottawa. My bad. That's actually Ottawa. Or no, that's Quebec. Because Ottawa is actually, I believe, over here. Montreal is actually here, north of New York. Yeah, because that's like one of the largest cities in Canada. And Quebec City. So this is Montreal. Where is that Montreal there? I believe that's Ottawa, because Ottawa is a capital, but it's not a very large city. Yep, Ottawa is actually, yep, that is Montreal. Yep, I was actually right. That is Montreal. Just Quebec City is right here, but it's covered in fog, so you can't see the city lights. Yeah, in fact, cloud cover actually really does cover the cities. So this is actual real-time image, and I don't know if what you're seeing is actual, like, if the lights that you're seeing are like artificial put there to make it so you can see the cities, or is it real? Because perhaps it is, because this is most likely a geostationary satellite. So Quebec City's here, Montreal, Ottawa. Yeah, because that is Montreal here. Or in Canadian, it's not Montreal, it's Montreal. It's Montreal, which means Mount Royal or Royal Mountain. So the shear is starting to weaken, but you see how everything is moving west-east. That's the shear right here. But the shear is weakening. And slowly, but you see dry air. See, there is some dry air working into the system. I mean, there is a possibility that low pressure center could actually try to relocate itself further east to relocate itself towards the thunderstorms. That is definitely a possibility because low pressure centers typically do that. I mean, tropical systems typically do that. And in fact, there's actually another little low pressure system, a small one, that is trying to develop. Well, based on what I'm seeing on radar, let me see if if it's actually causing any wind shift. Yeah, there actually is. There's even some water spouts I'm seeing on looking at the velocities. But there is another low pressure system that's trying to develop, actually east of Cape Fear, I believe. Let me see what cape that is. It's okay. I'll show you where. So there's another low pressure system. So this is Cape Fear, right? Cape Lookout. Sorry, Cape Lookout, and there's another low pressure system trying to develop here. So you have one over here. And you have another one that's barely noticeable over here, but it's embedded in the precip. So that could become the dominant one, or the dominant one could be where some of the thunderstorms are. But it'll be more likely where you're having the general swirl. You might have it relocate over here. If it relocates here, if it relocates further east, it'll stay over the warmer waters and have less interaction with land, which means it could develop stronger, faster. But the most noticeable swirl is still here, southwest or southwest of Cape Lookout. And looking on the satellite, southwest of Cape Lookout, which is here, it's the second one. It's not this one. It's Cape Lookout is actually here. So this is Cape Lookout right here. Nothing. You can see no convection of any kind. But there's another swirl that is further west. It's not very noticeable, but it's there. It's more like over here. Currently, the low pressure center is very broad, does not look like it's a tropical storm or even a depression. It doesn't look much of anything at the moment. Okay, guys, I'm going to be going to bed in a couple minutes. I just want to show you one more thing before I go. Let's look at water temperatures here. 76.1 degrees. That says, yeah. So again, water temperatures are very warm. This is New York Harbor entrance buoy, I believe, right? Yeah. 77 degrees. So this further south. And so yeah, water temperature 77. I mean, the water temperatures might be cooled down a little bit by some upwelling, but water temperatures are very, very warm. I mean, you might say this is not very conducive, but it kind of is conducive in some ways for some development. Water temperatures off of Virginia Beach are in the mid to upper 70s, around 77, 78 degrees. Okay, that's not very conducive, if you ask me, but you have two buoys right next to each other. You have SCRIPPS, or Scripps, buoy station 44088, and another buoy that is station 44014. That has a surface temperature of 77.9 degrees. It is just near the Gulf Stream. It's like on the east, just on the eastern periphery, or the western periphery of the Gulf Stream. Hudson Canyon. That is Baltimore Canyon right here. I don't know whether it's not mentioning Baltimore Canyon. Hudson Canyon, maybe that's Baltimore. Okay. Hudson Canyon is actually from the Hudson River. So there, you can see the Hudson River here. The Hudson Canyon is part of the Hudson River. See all these river outlets, this is all from because of rivers. Yes, rivers actually carve paths, even when they never really stop flowing. Like Hudson River, you think, oh, it enters the water and that's it. It basically like branches out. Not necessarily. Not all rivers do that. In fact, the only river that kind of does that is the Gulf of Mexico, is the Mississippi River, but even then, Mississippi Valley. So you're having a mid-Atlantic ridge over here. And then you're thinking, where is a subduction zone that would normally be opposite facing? I mean, look, you have subduction zones here. And you have a trench here. You have a subduction zone here with volcanoes and Leeward Islands. But there's no subduction zone on the East Coast, right? And you think Portugal doesn't have a subduction zone? Well, it does. There was an 8.5 earthquake at one point that that produced a tsunami that hit Lisbon in ancient times around 60 BC, and you have the Lisbon earthquake that happened 300 years ago, a little over, you know. Yeah, the Lisbon earthquake that happened right around the time of the American Revolution. 1755. I'm saying right around. And look, it was between 8.5 and 9.0. That's a mega thrust earthquake. It was a thrust fault. I mean, this earthquake was a mega thrust earthquake. Let's look at the geological setting. Look at that. That's a tsunami, basically, and all the fires from the earthquake. But here's the thing. The earthquake wasn't right where Lisbon was. It was some distance away. Lisbon is almost at 40 degrees latitude. The earthquake was around 36. So this is like the earthquake happening in Delaware, and you're being near New York City, and you're getting all that damage. Looks like a lot of areas got impacted. Even Casablanca and Rabat might have been severely impacted by the earthquake. Commentary reports say the earthquake lasted between 3.5 and 6 minutes, which is basically a subduction zone. Subduction zone quakes are notorious for lasting a very long time. Especially 2011 Japanese quake lasted a particularly long time. There was even some small tsunamis on the East Coast too. There was even some waves that impacted, the United States. It wasn't big, but there was. Shocks from the earthquake were felt throughout Europe as far as Finland and North Africa. And according to some sources in Greenland and the Caribbean, tsunamis as tall as 20 meters swept the coast of North Africa and struck Martinique and Barbados across the Atlantic. A 3-meter hit Cornwall on the southern British coast. Galway, wow. And partial destruction of the Spanish Arch section of the city wall. it is revealed that the tsunami waves may have reached the coast of Brazil. Then colony of the then a colony of Portugal sent letters by Brazilian authorities at the time of the earthquake described damage and destruction caused by gigantic waves. Well, seismologists and geologists have always agreed that the epicenter was in the Atlantic to the west of the Iberian Peninsula. Its exact location was a subject of considerable debate. Early hypotheses had proposed the Gorinch Ridge until simulations showed that a source closer to the shore of Portugal was required to comply. A 1992 seismic reflection of the ocean floor along the Azores-Gibraltar transform fault detected a 50-kilometer, 31-mile-long thrust fault. So, southwest of Cape Vincent with a dip-slip throw of more than 1 kilometer. This structure may have created the primary tectonic event, but it wasn't the first one either. There was one that happened in thousands of years ago too, about 2,000 years ago. A little over 2,000 years ago, it happened again. So the fact that it's subducting means it's a new subduction zone that is starting to form, basically. Mm. It's mostly a transform fault, though. But the fact that you're having a thrust fault forming here means that you're eventually going to have volcanic eruptions. You're eventually going to have volcanic formations forming. Again, let's look at the radar again. I'm going to look at it one more time. I'm going to wake up around 7 a.m. to do another update, and that's all. That's all I have for now. Thank you all for watching, and I want to wish everyone a good night. Make sure I ended the stream. Thank you so much for watching. Yes, I do think you're right. I do think it'll go straight through New Jersey, especially with what the models are showing now.